Okay, let's see whether. Okay, fine. Good morning, everyone. Uh, this is a class of geotechnical engineering, module 2, that is permeability of soil. So, till now, we have discussed about uh, basics of permeability of soil, which is basically a property of soil which allow passes of water through its interconnecting voids. We have discussed about seepage velocity and discharge velocity and factors affecting permeability, and also we have discussed about uh, different laboratory tests. Mainly, two tests are available, which are generally used for determination of coefficient of permeability for fine grained soil and coarse grained soil separately. Okay, and in the last class, we have started discussing about stratified soil. That means how to find coefficient of permeability in case of stratified soil. As we already discussed in previous class, that coefficient of permeability is depend on the direction of flow when it comes to the stratified soil. Okay, if the direction of flow is um, okay, I'll just show my first screen. Okay, wait, let's try. Okay, first of all, whether my screen is visible or not, please respond. Okay, take it, thank you. So yeah, we have discussed till now. In the last class, we have discussed about stratified soil, isn't it? Permeability of stratified soil deposit. So here we have discussed about two cases. That means when the flow is parallel to the bedding plane, and second case is when the flow is perpendicular to the bedding plane. For these individual two cases, we can determine coefficient of permeability. Okay, since in both cases some conditions are different. What kind of conditions are will be different? Say for coefficient of permeability, when the flow is parallel to the bedding plane, in that case we can consider the hydraulic gradient for which the flow is occurring. The hydraulic gradient will remain same for each layer of the stratified soil. Okay, but the velocity of flow, that is V, the discharge velocity or Darcian velocity, the velocity of flow will not going to be same for all layer. It will vary. Okay, in case of flow parallel to the bedding plane. Okay, now when it comes to perpendicular flow, when the flow is in a perpendicular direction, so we have seen that the hydraulic gradient in that case, it will not going to remain constant for each layer. Okay, for each layer hydraulic gradient will be different, and the summation of the hydraulic head for each layer, the summation of hydraulic head for each layer is equal to the total head difference, that is capital H. Okay, that's why here you can see, sorry, not capital H, small h. Okay, the small h here you can see small h is a summation of h1 plus h2 plus h3 up to hn, where h1, h2, h3 or hn are what? They are the head difference or the hydraulic head for individual layer. Okay, that means because of this h1 hydraulic head difference, the water flowing through this h1 this layer. Okay, I'm talking about this layer now. So because of h1 hydraulic head, the soil passes through this layer. Okay, like this. So water is going through in this direction, so we can say water first enter this layer, the last layer, then it will go upward direction. Since the initial, the average total head, you can say total head is in this direction. That means this overhead tank is a higher elevation in this direction, so water is obviously flow from bottom towards the top direction. Okay, and finally we have got two equation for coefficient of permeability in x direction and z direction. So here you can see kx is represents what? Kx represents your coefficient of permeability when the flow is parallel to the bedding plane. Now when the flow is parallel to the bedding plane, you have to use this formula, that is k1 into z1 k plus k2 z2. Simultaneously, it's up to the how many layers are there divided by total thickness of the layer, that is z. Okay, so using this formula you can find out average coefficient of permeability for a stratified soil when the flow is parallel to the bedding plane. Now, in case of perpendicular to the bedding plane, we can find out coefficient of permeability using this formula. Now, in this case, you can see the difference between this formula and this. Here, thickness is at denominator and it is numerator. Okay. Now, here you can see Kz is what is equal to total thickness, that is Z. Okay. Or you can also write down Z1 plus Z2 plus Z3 up to Zn. Okay. So this Z divided by Z1 plus K1, that is your for first layer, Z2 plus K2 for second layer, it will go on like that. So using this formula, you can find out coefficient of permeability of stratified soil when the flow is perpendicular to the bedding plane. Got it? So these things are already discussed in last class. So let's find out going through one problem. Okay, a physical problem. Let's see. Okay. Okay. So I think you can see this. Let me first. When I it again. Okay. Okay. So here, this is a problem. Here you can see. So what is given in the problem statement? A stratified soil deposit consists of 4 layers of equal thickness. Okay. That means stratified soil is exists, suppose, and having 4 layers. This 1, 2, 3, 4. 4 layers are given here, and having equal thickness. Suppose the for first layer, if you consider the thickness is Z1, okay, then all the other layer also we can put Z1. That means Z1 equal to Z2 equal to Z3 equal to Z4. That means for each layer thickness is same. Okay. Now average coefficient of permeability is given as the average coefficient of permeability of the second, third, and fourth layers are respectively 1/3, half, and twice of the coefficient of permeability of the top layer. That means it is saying that if you consider for a first layer coefficient of permeability as suppose K, then the coefficient of permeability of the second layer, say K2, will be how much? 1/3 of the first layer. Okay, and the third layer is equal to half of the first layer. And the fourth layer, that means the coefficient of permeability for the fourth layer, that is K4, it is equal to, here you can see, given twice of the coefficient of the first layer, that is twice of K1, like that. So it is given as a condition. Okay, now you need to compute the average permeability of the deposit parallel and the perpendicular to the direction of the stratification in terms of the permeability of the top layer. That means you need to find out coefficient of permeability for both cases. That means considering flow parallel to the bedding plane, and second case considering flow perpendicular to the bedding plane. It's a very simple problem. Okay, so here you can given. Okay, first of all, this problem it is mentioned. It's given in a soil mechanics foundation engineering book of BC Punmia. Okay, you can also go and look at that problem. So here, as for solution, it is given as let the thickness of the top layer is Z. Okay, and the coefficient of permeability is K. That means for the first layer or the top layer, let's consider the thickness of the layer is represented by Z, and let's say the permeability of the first layer is K. Now, since all having equal thickness, that means others, the second, third, and fourth layers, all these other layers also have the same thickness, that is Z. So we can find out the total thickness of the deposit will be the Z plus Z plus Z plus Z. That means 4 Z's are there. That means 4Z. Okay, it's very simple to understand. Total thickness of the deposit will be 4Z. Okay, now as per our second condition is given as of the coefficient of permeability. So here is given, let's say, okay, let's say, wait, someone is waiting in the lobby. Okay, so since we know we have what we have taken for first layer, we taken as a K1. For second layer, it's K2, like that, now generally. So in this case, in this problem, we can say K1, since we have taken as a first layer, for the first layer, coefficient of permeability as K. So in this case, K1 will be equal to K. Okay, for the first layer. That means coefficient of permeability for the first layer. and K is all we have already assumed it. Next, K2, that is the coefficient of permeability for second layer. Now it is given as for the coefficient of permeability of the second layer is 1/3 of coefficient of permeability of top layer. That means we can say K2 equal to 1/3 of K. Similarly, K3 equal to half of the K. It is given now. Third layer is half of the coefficient of permeability of top layer. It means we can say K3 equal to half of K, but it is K by 2. And the fourth layer, that means coefficient of permeability for the fourth layer will be twice of K. Okay. So after getting this all this value, we can what we need to do only just put all this value in this equation. That means when the flow is parallel to a bedding plane, represented by Kx using this formula, that is what is the formula? Actual formula K1 Z1 plus K2 plus Z2, K3 Z3 like that, na? So for the first layer, it is K, Z into K. Okay. For second layer, Z, it will remain same because for each layer Z is same, but in place of K, we have to put K by 3. Now for third layer, Z into K by 2. Fourth layer, Z into twice K. Okay, and the total thickness is 4Z. Just you have to solve this, you will find out this. Okay, you can also do it by yourself. Simple mathematics. Same way, you need to find out Kz. And finally, you will get this value. Okay, you can also try by yourself. Okay, it's a very simple question I have shown you. Okay, and in generally in a competitive exam, this kind of problem usually asks. Okay, since this is very simple to do within a very few time, but it's very difficult to understand the formula or remember the formula. Not that difficult. If you can understand, you can also find out. It's very easy to remember even. But in some exam, this kind of problem may ask about you. Okay, so you need to remember this value of kz and kx and kz. Okay, so try this. Okay, you will find out this value. Okay, similarly, I just want to show you another one. Let's see it is available or not. Okay, I think you can see this. Okay, so this problem is already came in some engineering service exam 2002. Okay, this this problem also I have taken from the same book, BC Punmia. So what is written here? So it's asking you to find out. So it's asking that what will be the ratio of average permeability in horizontal direction to that in the vertical direction for a soil deposit consisting of 3 horizontal layers if the thickness and permeability of the second layer are twice of those of the first and those of the third layers twice of those of second. So it's look like little bit complicated. The problem statement is little bit lengthy and little not easy to understand, but actually it is very easy to do. Okay, so first of all you have to understand this language. Okay, and you have to go step by step. Okay, now in this question what is given, you need to find out the ratio. That means into excellent. You need to find out the ratio. That means ratio of average permeability in horizontal direction to that of vertical. That means you need to find out kx or by kz. Okay, here you can see at the end also you can retain k in place of kx, it is written as kh. So not a big deal. H for horizontal, you can also put x or h. In place of z, you can also put v for vertical. Okay, so don't confuse here, they are same. So you need to find out the ratio of kx, or kh by kv or kz. That means you have to understand, you need to find out the value of kh and kv also for that to find out the ratio. Now, as a condition, what is given as it consists of 3 layers. That means you have to understand that the stratified soil contain 3 layers now. Okay, now you have to consider that it must be contain coefficient of permeability K1, K2, and K3, and thickness Z1, Z2, Z3. Find out. Okay, you can also draw the drawing also. Now, what condition is given here? If the thickness and permeability of the second layer are twice of those of first layer. Okay, hold on up to this. Now, consider K1 and Z1 are coefficient of permeability and thickness of the first layer. Okay, let's say K1 is your coefficient of permeability of first layer, Z1 is your thickness of the first layer. Okay, now as for this condition, it is given here the thickness and permeability of the second layer, that is thickness, that means Z2, and coefficient of permeability, that is K2 for second layer. This K2 and Z2 are twice of those of first layer. That means you can write K2 equal to twice of K1, Z2 is equal to twice of Z1. Simple. And those of third layer twice of those of second. That means K3 will be twice of K2. Okay, and Z3 will be twice of Z2. Now you need to put in this place, in place of K2, you have to put the value of K2. Now automatically it will come 4K1, which is equal to K3. And in place of Z3, we can find out 4Z1 by putting the value of your Z2. Here Z2 equal to twice Z1. Na? So you will find out, you will get 4Z1. Now it get very simple. Now see, now you need to find out the total thickness of the layer. Okay, now you know what is total thickness. Thickness of the summation of the each layer. Now for the first layer, what is the thickness? We have already considered as Z1. Now what is the thickness of the second layer? Twice Z1. And for the third layer, 4Z1, isn't it? So here, what is the summation of the total thickness is come as 7Z1. 4 plus 2 plus 1, that is 7Z1. Now this equation formula become very, the problem becomes very easy. Just you need to put the value. The coefficient of probability in horizontal direction represent as what? K1 Z1 plus K2 Z2 plus K3 Z3 divided by total thickness of the layer. Now in place of K1 Z1, it will remain there as a for first layer. For K2 Z2, in place of K2, you put twice K1. Where? Twice K1, and Z2 represents twice Z1 here. For K3, K3 represents your 4K1 and Z3 represents 4Z1. So, and finally, total thickness 4Z1. Now, solving this, you will find out, you will get this value. You just do by yourself. Okay. Same way, you can find out the value of Kv, that is vertical direction, the coefficient of probability when the flow is in perpendicular direction, Z direction or vertical direction. By putting this value, you will get this value. You just try by yourself. After getting this value, you just simply, what do you need to do? Just find out the ratio, Kx by Kv. And finally, you will get this value. You just try by yourself, okay? Okay, you just write down this in your notes and try to solve this problem. This kind of problem also come in competitive exam. Okay, even in your exam also, this kind of problem may ask. Okay, it's very easy to do, but only one difficulty is that you have to remember the formula for Kx and Kv, and don't mix up. Okay, usually student, what we do, we somehow we mix up the formula. Okay, try practicing the formula for Kx and Kv. Okay, after 1-2 times you will get the idea. Okay, even though if you can understand the derivation, from the derivation itself, it's very easy to understand. Okay, so this is all about today class. I have shown 2 problems. You can also try this similar problem related to coefficient of permeability through stratified soil. Okay, it's very easy to understand and easy to do. Okay, so here I want to close my sharing now. Wait. Okay, understood these 2 problems? Is there any doubt related to these 2 problems? You can ask me. If there is no problem, oh, okay. You can't hear me. You should tell me earlier. I'm just speaking like that. Okay. My voice is not clear or what? Please do response.
Yes, sir.
Okay, clear now. Maybe for somebody, the voice is not clear. Anyway, I'll upload this recording, so don't worry. You will just go through the recording, and even though if you got any problem, you just WhatsApp me. I'll just give an explanation for the problem. So don't worry, and it is very easy to understand. If you can understand the derivation of the coefficient of permeability for stratified soil, if you can understand, then you can also you will understand the problem. It is not that difficult. Okay. So if it is clear, then I'll just stop my recording and I'll take the attendance. Okay. Fine. Wait a second. Okay, I'll stop my recording first.